to do past paper, we can say that kinetics has divided into multiple portions. Like in the first portion, you would be writing rate equation, and also to find the unit for the rate constant. Okay. And also in another portion, we would be finding out the order of reaction, and then we would be finding out half-life. Okay. And also order of reaction by using half-life. You would be given a graph in that we would be using. Okay. Another portion, we would be writing down the reaction mechanism. Okay. Or and different graphs. So see this. Uh, this is called the rate equation. Basically, rate is directly proportional to the concentration of reactants. If you are going to increase the concentration of reactants, so obviously the rate of reaction is going to increase. Okay. So rate increases by increasing the concentration of reactant. They are directly proportional to each other. And obviously, if you are going to decrease the concentration of reactant, so the rate of reaction is going to decrease, you can say. As you can see, this is K, this is the rate constant. Okay. So whenever you would be given any equation, so you can find out the rate equation. As you can see, this is contact process. This is contact process. Uh, let's suppose I am asking to write down the rate equation for this reaction. So what you would be doing, you would be taking the reactant side, okay, that is sulfur dioxide and oxygen, and coefficient would become coefficient would become power of the reactant. And then obviously this is my rate equation for the same reaction. And then you have to find out the unit for the rate constant, that is K. That is K. Okay. So K would be equal to rate over the concentration of reactants. Okay. And the unit for rate is mole per dm cube per second. Why? Because the rate is change in concentration per unit time. Change in concentration per unit time. What is rate? Change in concentration per unit time. So concentration means it's mole per dm cube, and time we can measure in seconds. Time we can measure in seconds. Okay. So that's why I'm saying the unit for rate is mole per decimeter cube per second. Okay. Let's suppose I'm going to find out the unit for K for this reaction. So K would be equal to rate over the concentration of reactants. Rate is mole per dm cube per second, and concentration is mole per dm cube and mole per dm cube. Okay. So let's simplify this. It's power 2 and it's power 1. So that would becoming power 3. I'm going to add them together because the base is same. When the base is same, you can add the powers. Okay. So that would be 3. This is mole per dm cube. This is mole per dm cube raised to the power 3. Ultimately, in the denominator, that would be remaining, that is mole per dm cube raised to the power 2. And then I have applied 2, so it would become mole 2 and then dm6 minus 6, and per second would remain the same. So after simplification, it would become mole minus 2 dm plus 6 in per second. This is the final unit for this reaction. Okay. So I haven't shown the step, so you can just show all these steps. It's very easy. Uh, if you are given this equation, that is the Haber process, and we are going to ask that you have to write down the rate equation, and then you have to find out the unit for the rate constant. So can you tell me the unit for the rate constant for this reaction? Yes. Hmm. Yes. Yes.
Sir, is it mole 3, DM9, and S minus 1?
Mole minus 3, dm positive 9, and per second. Okay.
Okay, sir.
And also, uh, you know, whenever we are going to write the powers to the reactant by looking at equation, so it doesn't mean that you are going to tell like the let's suppose for this equation, when we are going to double the concentration of sulfur dioxide, so according to the theoretical concepts, the rate would increase by 4. The rate would increase by 4. But when you are going to do an experiment, if you are going to see the same thing, so that's true. And if you are not going to see the same thing, so means that this is fake. So in general, mostly we cannot tell the, you can say, order of reaction. This is order. Obviously, this is order. I told you that what is order? So it's the power of the reactant in the rate equation. So we cannot decide order of reaction by just looking at the rate equation. Whenever the examiner is going to ask to write down the rate equation, that's true. Okay, that's okay. But just looking at the equation, and you are going to predict that if you are going to double the concentration of reactant, so the rate would double. So the rate would be increasing 4 times. So the rate would increase by 9. So it's not true. You have to see experimental data. You have to see experiment. It's total experimental work. We cannot tell without doing an experiment. It's an experimental method. So hopefully when uh, you were doing past papers related to like kinetics, so you saw many questions related to that. Examiner has given you the whole data in the form of table, and then he asked to find out the order of reaction. So basically, that's why I'm saying it's totally experimental work. Let's suppose in this question, as you can see, he has provided you a data in the form of table, and then he is going to ask to find out the order of reaction with respect to ClO2 and then with respect to OH. Then we would be doing this. We would be solving the whole thing. So that's why I'm saying it's totally experimental work. Okay. But before going to do this, let me tell you that we would be studying three types of orders. Number one, zero order, then first order, and then second order. Zero order means that uh, any concentration of the reactant raised to the power 0. Any concentration of the reactant raised to the power 0. Okay, this is called zero order. And and if you are going to increase or decrease the concentration of A is any reactant, it's arbitrary, any reactant. So the rate would not change. The rate would not change. If you are going to increase or decrease the concentration of A, so the rate would not change. Means that this is zero order reaction. Okay? No effect on rate after increasing or decreasing the concentration. And then for first order reaction, raised to the power 1 means that if you are going to double the concentration of A, so the rate would double. If you are going to increase the concentration by 4, so the rate would be increasing by 4. Okay. And if you are going to decrease the concentration of A by half, so the rate would be decreasing by half. So the rate would be decreasing by half. Okay. So means that this is the first order reaction. And for second order reaction, raised to the power 2, if you are going to increase the concentration, like if you are going to double the concentration, so the rate would be increasing by 4 because this is power 2. Okay, this is the relation that we would be building up during the question. Okay, or you can say, uh, then if you can see, these are the graphs. Let's suppose for zero order, rate versus concentration. Rate versus concentration. It means that you are going to change the concentration continuously. See this, look at carefully. You are continuously changing the concentration. You are continuously changing the concentrations, but there is no effect on rate. Obviously, I told you this. Whenever you are going to change the concentration of reactant for a zero order reaction, so the rate would remain the same. Okay, so that's called zero order reaction. So this graph is showing zero order reaction. And if you are changing x's, if you are changing x's, so it's concentration versus time. It was rate versus concentration. It's concentration versus time. Okay. So you are changing the concentration, and this is the time. Time is also changing. So you will see that uh, again, you will see that if you are going to find out the gradient of this graph, so you will see the gradient would remain the same. It means that it's zero order reaction. What is the difference between this and this? There is no difference. You can see it's when you're going to consider reactant side and when you're going to consider the product side. It's the same thing. It's the same thing. And for a first order reaction, whenever you can see these three graphs, so you can decide that these are the graphs for the zero order reaction. Okay, for the zero order reaction. And if you can see these two curves, so you can consider that it's for the second order reaction. Okay, so you have to memorize the shapes of the graph. It would help you a lot. It would help you a lot basically. Okay, and uh, let's suppose I'm going to do this question. Okay, first of all, according to the marking scheme, you will see that they have mentioned in terms of wordings, in terms of wording. Let's suppose I'm saying I want to find out the order of reaction with respect to ClO2. So you will see that to find out the concentration of ClO2, you have to select those experiments. You have to select those experiments in which the concentration of OH is the same, as you can see experiment 1 and 2, because I want to change the effect of this. So why it should change? No, it should not change. It must not change because I want to study the change in concentration on the rate. If you will see those experiments in which the both are changing, so how can you study the effect? If you remember in the whole experiment, uh you can say, let's suppose in physics, in every subject, like science subjects, whenever you are going to do an experiment and you are going to study one thing, so the other factors should remain the same, should remain constant. Okay, to for the better result, okay. That's why I took experiment 1 and 2, because the concentration of OH is the same in 1 and 2, and these are different. Okay. Now you can see the concentration is exactly doubled. The concentration is exactly doubled. Basically, Basically, I have doubled the concentration of ClO2. So as a result of this, I would see the rate. I would see the rate because I have to change the concentration. Basically, I have to change the concentration. I have to change the concentration, and then you have to see, you have to see what is the effect on rate. What is the effect on rate? So obviously, if you can see the rate, obviously, if you can see the rate, rate is also, you can see the effect. Uh, these numbers are confusing for you, let's suppose. So to make this thing more easier, you can divide. You can divide. Can you tell me, if you are going to divide these two numbers, so what is the number that you are getting, so that we know it's increasing by 2, it's increasing by 3, it's increasing by 4, it's increasing by 9, it's increasing by 12. So basically you have to divide these two values to get an idea. So can you tell me, if you are going to divide these two numbers, so what you are getting? Yes,
Sir,
4,
I'm
sir.
getting 0.
exactly 4. 4, 4. 9.34 over 2.33. The power is the same, so you are not supposed to include in calculation. It's up to you to make it easier. So you would be getting 4. So means that if you are going to increase the concentration of reactant by 2, if you are going to double the concentration of reactant, so the rate is increasing by 4. What does it mean? It's second order reaction. In the first order, it's directly proportional. If you are going to double the concentration, so the rate doubles. If you are going to increase the concentration by 4, so the rate increases by 4. If you are going to halve the concentration of reactant, so the rate decreases by half. But in this case, you are going to do it by 2, it's increasing by 4. It means that this ClO2 has second order reaction. Now you can check, now you can check OH. Now you can check OH. So for OH, I have to select those experiments in which the ClO2 would be the same, because I want to study the effect of the concentration of OH ion, not for the ClO2 ion. It would interfere your concept. It would interfere your, you can say, reaction. So that's why I'm going to take those experiments in which this would be the same, and this would be different. So that's why I have taken experiment 2 and 3. No, experiment 2 and 3, yes, exactly. So now you can see I have just double the concentration of OH minus ion. So you have to study the effect on rate. Are they doubled, tripled, quadrupled? So what is the change on rate? It can be easily determined if you are going to like divide these two values. Can you tell me an answer after dividing these two values? Yes.
Sir, 2.
2. Okay. So means that if you are going to double the concentration of reactant, so rate also doubles, which means that this is first order with respect to OH minus ion. This is first order with respect to OH minus ion. So in this way, you can find out the order of reaction for each and every question. Okay, so this is the method. Rest of the things you can do this, you can do this, you can use this relation. Okay, so let's suppose the relation says C2 upon C1 is equal to R2 upon R1, and this is the order of reaction. Now you can see for ClO2, when I have taken experiment 1 and 2, so I took these two values. This is C2 and this is C1. C2 upon C1 is equal to R2 upon R1. Okay, so I got this. So I told you before that it is second order reaction with respect to ClO2. And then if you are going to find out the order of reaction with respect to OH minus, So when you are going to take experiment 2 and 3, so that would be C2 and this is C1, this is R2 and this is R1. So then when you would be solving this, so you would be getting the first order reaction. With respect to ClO2, this is second order, and with respect to OH minus, this is first order. That's the thing, okay? And after getting the order of reactions with respect to ClO2 and OH minus, then you can make your rate equation, okay? And after making your rate equation, you can find out the unit for K, as you found the unit for the Haber process and the contact process earlier, okay? That's why we are going to find out the, you can say, order of reactions with respect to each reactant, okay? See this question. First of all, you have to find out the order of reaction with respect to NO and O2, and then you have to make a rate equation, and then you have to find out the unit for the rate constant. Okay? Can you tell me this? But fast. Fast.
सर एनओ के हिसाब से 1 होगा और
और O2 के हिसाब से? Yes, Tara, what do you think? I'm looking at 2024 paper. There is no question related to you can say order of reaction. So I want to do some recent questions related to the order of reaction.
सर एनओ के हिसाब से 2 होगा और ओ के हिसाब से O2 के हिसाब से 1 होगा
NO के हिसाब से 2 होगा और O2 के हिसाब से 1 होगा, ऐसे ही है?
जी सर
Okay. Tala, can you confirm so that we can go ahead? Or you are not able to do so? Should I do this question? Hmm? Fast. Yes. Can you hear me? Hello? Tala, can you hear me? See this. I did this question. बासिल तुमने यही बोला था ना 1 and 1? या तुमने 2 और 1 बोला था?
2 and 1
नहीं ना, 2 and 1 तो नहीं है।
एनओ के हिसाब से 2 नहीं
So I got a question from 2023 paper. Okay, 2023 paper. Or Tala, you left. I was asking. Okay, I was asking this question.
सर
I
आपने
was,
ये कल करवाया था इसमें 2 and 1 नहीं होगा
ये देखो मैंने चेंज तो किया था, ये नहीं किया था क्या
Question.
चेंज?
एनओ के
Sir,
हिसाब
which
से 2
question?
और O2 के 1
This question, Tala, this question. NO के हिसाब से, okay. I took experiment 2 and 3, okay, 0.064 over 0.032, so this is 2. And then this is 3.28 over 8.15. इसको divide कराओ जरा, क्या आ रहा है?
Sir, can you explain?
Yes. Fasil, क्या आंसर आ रहा है?
सर 2
So
सॉरी
for
3.8
Sorry, 3.8.
नहीं नहीं, एक मिनट में कर रहा
अबे यार,
हूँ सर। 4।
4 आ रहा है. ओके ओके ओके. So then this is 2, right? X is equal to 2. Tala, I was saying that, did you listen this question so that I can tell you
Yes,
another
sir.
question? Okay, that's good. Basically, you have to find out the order of reaction for another question. Obviously, then you have to select an experiment if you are going to find out the order of reaction with respect to NO. So I took experiment 2 and 3. Oh, I took experiment 2 and 3. So I got this and this rate and concentrations. And after calculation, I got second order reaction. And if you are going to find out the concentration order of reaction with respect to oxygen, so I took experiment 1 and 2. As I told you that you have to select those experiments in which another should remain the same, because I want to study the effect of changing the concentration of that particular reactant on the rate of reaction. So other factors should remain the same. So that's why I took experiment 1 and 2 for oxygen. Okay. Uh, then after calculation, I got 1. So with respect to O2, it's first order, and with respect to NO, it's second order. In this way, you can find. Okay. Um, I'm going to send the very recent question. It's 2023 paper, or it's of 1 mark. They are asking to find out the rate of reaction basically. And okay, no, it's easy. I should not do this question. And okay. Let me take another paper. So while you should do this question, you should do this question, Tala. Then I'm going to tell you that how you can do this question. It's some, it's somehow different. It has a different concept basically, because in this question you can see nothing is same in the first column. Every reaction, every concentration is different. Every concentration is different in this question. So when every concentration is different, then what you are supposed to do? So first of all, you are supposed to find out the order of reaction with respect to CH3CHO. Okay, with respect to this, because this and this are same, you can take experiment 1 and 2 to find out the order of reaction. Then I would say, then I would tell how you would be finding out the order of reaction with respect to OH minus. Despite the concentration of this side is not the same, but first of all, you are supposed to tell me the order of reaction with respect to CH3CH2. Yes,
Sir, is it first order?
first order. Okay, good. It's first order reaction. It's first order reaction. And then when you are going to find out the concentration of order of reaction with respect to OH minus. Okay, so despite this is not the same, but I am going to take I am going to take uh, experiment. I am going to take this and this. Okay, as you can see, 0.03 over 0.015. Okay, 0.03 over 0.015. And ultimately, I know the order of reaction with respect to CH3CHO. Okay, that is 0.4 and 0.1 concentration. Basically, I have taken experiment 1 and 3. I have taken experiment 1 and 3. And for this, I have taken experiment 1 and 2. So I have to find out the order of reaction with respect to OH minus. So I have mentioned that this is Y, which is the order of reaction with respect to OH minus. And then I know the order of reaction with respect to CH3, CHO. So just I put 1. Just I put 1 over here. After simplification, you will get 2, then 2 raised to the power y, then this would be 4 to make it. So just simplify this. This 2 is multiplying over here, so it would divide by 4 and you would be getting 2 again. So you can cancel the base, okay, and then you would get 1 again. So this is the first order reaction with respect to OH minus. Whenever you can see these type of questions in which the concentration is not the same, because when the concentration is same, so it would be very easy for you to calculate the order of reaction with respect to each and every reactant side, okay. But if you have these type of questions, so first of all you can find out the order of reaction of the of the reactant in which you can see the same concentration, okay. Then you can do the next step. Let's suppose you have this question, okay. uh let's suppose you have this question, and okay. uh, you can do this. Can you tell me the order of reaction with respect to this? Then I would be telling you what you are supposed to do.
सर दोनों के हिसाब से 1 है।
दोनों के हिसाब से 1, okay, let's see.
Sir, for C6H5, CHCl, CH3, it's first order.
And for another one, so you are supposed to first find out the order of reaction with respect to this, because this and this is the same, so you can study the effect, okay. So what I am doing, 0.15 over 0.05 raised to the power x, and 1.5 over 0.5. Can you tell me an answer? If you
3.
are going to divide 3 raised to the
Yes.
power x, and it's also the 3, so x is equal to 1. So I know the order of reaction with respect to C6H5, that is 1. And if you are going to find out the order of reaction with respect to OH negative, so which experiments you are supposed to take? First of all, tell me. Yes. Hmm?
So for
Second and
OH,
fourth.
Second and fourth. बासिल क्या कहते हो?
तो फर्स्ट एंड सेकंड से भी कर सकते हैं।
First and second से भी कर सकते हैं. Exactly. So let's
Why,
suppose
sir?
because it's getting doubled. It's also getting doubled. So you can take experiment 1 and 2 as well. So let's suppose I'm doing this 0.1 over 0.05 for this. I know the order, that is 1. and 0.2 over 0.1 is equal to 1 over 0.5. Can you tell me an answer? 0.1 over 0.05?
2.
2. This is 2 into, this is also 2. And what is this?
2 also.
So, so then what am I supposed to do?
Divide 2 over 2.
So this is zero order. When the base is not the same, so you can say that this is zero order reaction.
Sir, can you explain why you chose the first and second experiment?
You know, you can take any experiment in which you can, basically I'm going to find out the order of reaction, okay? So you can also take, let's suppose you were saying second and fourth, but you know what's the problem? In the fourth, the rate is not given. So that's completely wrong, obviously. That's completely wrong. So if you're going to take experiment 1 and 3, but the thing is that I'm going to find out the concentration of OH minus. So it should not be the same. It should not be the same. I cannot take 1 and 3. I cannot take 1 and 3, okay? So then the next possibility is obviously 1 and 2, okay? 1 and 2, and also yes, that's the same thing. That's why I have taken experiment 1 and 2. Okay? Tala, are
Okay,
you
sir.
getting? Yes.
Yes, sir.
बासिल क्या आ रहा था तुम्हारा? जीरो ऑर्डर आ रहा था या फर्स्ट ऑर्डर? Calculation is
सर
good.
दोनों के हिसाब से फर्स्ट ऑर्डर.
But I got this calculation, जरा कंफर्म करना ये सब सही है. 0.1 over 0.05, it's 2, right?
Yes.
And 0.2 over 0.1,
Yes, 2.
and this
2.
okay. Then 2 raised to the power x is equal to 1. So zero order है ये. Okay. So let's see the marking scheme. It's question number 6. It's question number 6. See this, it's zero order. Basil, can you see this?
Yes, sir.
When both concentrations are doubled, rate doubles. So the OH is zero, has no effect. Okay. Yes, can you tell me this order of reaction?
Sir, according to H2O2, it's 1.
Yes, sir, it's 1.
Okay, and with respect to H positive,
Sir, is it second order with respect to
okay,
H plus?
let me check this. So, which experiments you have taken to find out the order of reaction with respect to H positive?
Sir, with
Uh,
respect
Sir,
to
are
H
you
positive, it can
one
be
and
0.
can we let मैं चेक करता हूँ कौन सा एक्सपेरिमेंट लिया है बासिल इसमें आपने
Sir, 1 and sir, it with respect to H plus, it's 0.
कौन सा एक्सपेरिमेंट सेलेक्ट किया है वन
सर
एंड थ्री
पहले 1 and 2 से किया तो H2O2
वन एंड
का
टू से तो वन एंड टू से तो नहीं कर सकते ना इट्स द सेम व्हाई यू आर टेकिंग दिस
नो नो फॉर H2O2
वो तो सही है वो तो फर्स्ट ऑर्डर हो गया ना इट्स ऑलरेडी डिसाइडेड
जी
बट आई एम
then 2 and
आस्किंग फॉर
3
दिस देन
then
टू
2
एंड
and
थ्री
3
2 and 3 yes this is change and this is also okay so let's suppose it's 0.09 over 0.07 raised to the power 1 and it's 0.07 over 0.05 is equal to 1.8 over 1.4. Can you tell me an answer? 0.09 or 0.07? Yes.
9/7
नंबर बताओ यार
1.3, sir.
1.3. Okay. And what is this?
1.4.
And what is this? Yes.
1.3.
1.8 over 1.4 is 1.3, right?
Yes, sir.
Okay. So x, so nothing is going to cancel, so this is zero order. With respect to h plus, it's zero order. Let's check the marking scheme. So this is question number 19, okay? 19 part E. 19 part E. 19 part E is yes, H plus is zero order. H2O2 is first order. Okay, so this is easy. So now you can solve it. Okay, and also obviously I told you in this chapter we also do some reaction mechanisms and also uh, you can see the catalyst and the types of catalyst. There are two types of catalyst like homogeneous catalyst and also the heterogeneous catalyst. In this chapter, we would be studying in detail. Okay, what is the role of homogeneous catalyst? What is the role of heterogeneous catalyst? How it works? Let's suppose if you have a contact process, all are gases, so V2O5 is solid. So then you have to classify, categorize that is this a homogeneous catalyst or a heterogeneous catalyst. So basically, this is the topic that we would be studying later on. Okay. But right now, you have to do some questions related to the order of reactions and also how to find the rate equation, how to make a rate equation, and how to find the like the unit for like the rate constant. Okay.